In this video, I'm going to invite you to practice what you've already learned. There are 8 exercises here involving array variables and loops, which you might like to try coding up yourself. I'll show you what they do, and then it's up to you if you want to give them a go. Alternatively, you can jump straight to my solutions later on in this video. By the way, all of these programs start with the same 6 lines of code. All of them declare an array variable of integers with 5 elements, and then the array is initialized as you can see here. But it's important to realize that your programs have to work with any data, not just these. So let's see what they do. The first exercise is to output each item in a separate message box, one after another. Well, you've already seen how to do this in a previous video. I'm using a loop to scan through the array. Exercise 2, output all of the items in the same message box, but on separate lines. Exercise 3 is to add up all of the items and output the total in a message box. They add up to 75. In exercise 4, we calculate the average of the items. The average value is 15. Very similar to exercise 3, except we're dividing the total by the number of items. In exercise 5, we are only adding up the items that are bigger than 20. There are 2 items in the array which are bigger than 20, namely 33 and 22, and they add up to 55. We're still doing this with a loop, but as we visit each item, we're deciding whether it's bigger than 20 or not. In exercise 6, this is a little bit trickier. You have to find the largest item and output it in a message box. The biggest item is 33. And let's be clear, the program is working out which is the biggest item. If you can do exercise 6, you'll find exercise 7 very easy. Exercise 7 is finding the smallest item. And exercise 8 is replacing each item in the array with a new value that is twice as big. And then we output those values in pretty much the same way as we did in exercise 2. So if you want to give them a try yourself, pause the video now and see what you can come up with. Alternatively, you can jump straight to the solutions. So let's take a look at my solutions. The objective of exercise 1 was to output each item in a separate message box, one after another. You've seen how to do this in a previous video. I start by declaring an array of 5 integers, and then I initialize the array. In order to scan the array, I need a loop counter, so I've declared an integer variable called I, and that controls the number of passes through the for loop. Then I say for I equals 0 to 4, output AI data, element number I. So first time through the loop, I is 0, that outputs the first item. Second time, I is 1, I output the second item. And so on, until I is equal to 4, we output the last item, and we drop out of the loop. In exercise 2, we want to output all of the items in the same message box. So we don't have an output command within the loop, we're simply building a string. I've declared a string variable called stout, and inside the loop I say stout equals whatever it used to be plus the next item in the array. I'm also concatenating a new line operator on there as well, so the string actually contains the information needed to throw a new line between each item. When we drop out of the loop, we display the output string in one go. The solution to exercise 3 is similar to the solution to exercise 2. We want to calculate the total of the data items, so I've declared a variable called iTotal to contain this, and then as we visit each item in the loop, I say iTotal equals whatever it used to be plus the next item. I'm using the addition operator instead of the concatenation operator this time. When we drop out of the loop, I display the total in one message. The objective of exercise 4 was to calculate the average. Well, this is pretty much the same as the previous exercise. I calculate the total first, and then when I display the message, I simply divide the total by 5. With exercise 5, the objective was to add up all of the items bigger than 20. So in some ways it's similar to the previous program. I've declared a variable to hold the total, but look what's going on inside the for loop. I'm adding the next value to the total conditionally. I'm testing each value first to see if it's bigger than 20, and if it is, I add it to the total. If it isn't, well, I don't. If you think about it, adding up all of the items which are, let's say, smaller than 20 would require a very simple change. All I'd need to do is change this relational operator to a less than sign. In exercise 6, you were invited to write a program to find the largest item in the array. The principle behind this program is to visit each item in the array, and if it's bigger than the previous item, then keep a record of it. So I've declared a variable called iMax, which will hold the maximum value, and I've initialized it to 0, which pretty much guarantees that everything is going to be bigger than iMax to begin with, assuming I'm only working with positive numbers. When I visit the first item inside my loop, I ask, is it bigger than iMax? Well, of course, item 0, the number 5, is bigger than iMax. It's bigger than 0. So I'm assigning the first item to iMax, overwriting its previous value. iMax now contains a 5. 5 is the biggest item we've found so far. Second time through the loop, I examine the second item, and I ask, is it bigger than iMax? In this case, well, 7 is bigger than 5. So I replace 5 with 7. I'm keeping track of the biggest item. Third time through the loop, same question, and I replace 7 with 33. But fourth time through the loop, I find that 22 is not bigger than 33. So this line of code doesn't execute. By the time the program's finished, iMax contains the biggest value. If you can solve exercise 6, then you can solve exercise 7 very, very easily. This time I have a variable called iMin, which is going to hold the minimum value. And I'm initializing it with a very large value, something that I know is bigger than anything else in the array. I've made it 10,000. When I visit the first item, I ask, is it smaller than iMin? Well, of course it is. 5 is smaller than 10,000. So iMin becomes the first value. And then we proceed pretty much as we did in the previous program. By the time we drop out of the loop, we have the smallest value. The objective of exercise 8 was to replace each item in the array with a new value twice as big. I actually want to change the contents of the array, and that's what this loop does. It's actually very simple. I say let AI data, the item I'm looking at, be equal to itself multiplied by 2. So by the time we drop out of this loop, the array contains a completely different set of data. And then the remaining code simply outputs those data in a single message box, just like in exercise 2. Now, even if you didn't solve these problems yourself, it's well worth trying to duplicate the code that you can see here. It will definitely help you get a feel for using array variables with loops.